All right, let's now look at phase 3. So phase 3, we're going to solve two of the equations that we have here. So if you remember, recap from last time, we take a look at this. We had our three equations like this here, and we're going to solve these. We're going to pick two of them and solve them here. This one looks pretty simple here. It doesn't have an x minus, like, something a term. So I'm going to pick this one. So I'm going to pick this one and one other one. It really doesn't matter which one we pick. I'm going to pick these first two here. So we're going to choose those two. So we're going to choose PS and QT here, okay? So our equations look like this. Y equals C over A plus B times X. And we also have the other equation, Y equals C over B minus 2A times X minus 6A. Now, we can set them equal to each other and solve for x. But first things first, this looks not so great because as you can see here, we've got some denominators. So I think what we're going to do is we're going to try to simplify things a little bit to make things easier for ourselves. What I'm going to do is I'm going to clear the denominators out of here. I'm going to multiply each equation here to remove the denominators. So now this becomes y times a plus b equals cx here. All I did was just multiply by a plus b on both sides here. Over here, we'll do the same thing. So this becomes y times b minus 2a equals c times x minus 6a. Okay, so now what I'm going to do here, so let's get rid of parentheses, try to unpackage these. So this becomes ay plus by equals cx. That's useful. I hope it here. And then we have by minus 2ay equals cx minus 6ac here, right? All I did was unpackage everything, just rip everything out, and just look at distributed terms. Now this is quite nice, because notice we have a cx here, we have a cx here. So the next thing that we're going to do, what it looks like it's going to happen here, is we're going to substitute. This can now go in here. So now let's solve this. So therefore, we can now substitute this into that. So we get by minus 2ay equals ay plus by minus 6ac. And we're encouraged by this. This is actually quite nice, because if you take a look at the equation here, now we see there's a by on both sides. They're going to cancel out. And then I can gather this on the left-hand side here. So this becomes, I can subtract ay from this side and subtract ay from this side and get negative 3ay equals negative 6ac. That is fantastic here, because remember I was solving for y. And now I can divide both sides by negative 3a here. And when you do, you get y equals, and this also vanishes here, negative 6 divided by negative 3 is a positive 2, so we get a very nice y equals 2c. Very unexpected, but it works out really well. And now we can actually go ahead and finish this and solve this for x here by going back. So let's go ahead and do that here. So I'm actually going to go back and solve this for x and make this a little easier for ourselves. We're going to use this equation here, right, this again. So we have, so now I can take a bit of a detour here. Right, we'll go back here and then we'll go shoot off like this. So we know y is 2c, so I'm going to write 2c times a plus b equals cx. And nicely here you can see there's a c in both of these, so we can divide both sides by c. Those go away. And we're left with 2 times a plus b equals x, or 2a plus 2b equals x. So therefore, the intersection point of PS and QT, we're going to call that point here V. We're going to call that point here V. The point V has coordinates 2a plus 2b comma 2c here. Okay, so if we go back to our initial picture, here, this point V is the intersection of PS and QT here, the intersection of these two lines, and that intersection point has the coordinates 2a plus 2b comma 2c. So now we have to finish this off. Part 3 is finished. All right, phase 4. The last thing here, the last part of this is to check to see if V is on the third median. Right? I think you remember that here. So let's go ahead and finish that off. So now again, we're going to take that from before. V is going to be the 2a plus 2b comma 2c here, and the equation of the third median is going to be RU. RU here is going to have the equation from before. We had y equals 2c over 2b minus a times x minus 3a. Okay? So we're going to hope that this works here. So one thing we can do is, again, we can just substitute this in here, and we'll see what happens. I guess we'll see what happens. So we know that y is 2c. Is that going to be equal to 2c over 2b minus a times 2a plus 2b minus 3a? Oh, God, I hope it is. So we're encouraged here because we see the two c's look like this here, and it looks like the right side can't. We can simplify this a little bit. So there's 2c over 2b minus a. 2a minus 3a is just a negative a and a positive 2b here. And you'll note that this actually looks really nice here because these just drop out. And that is indeed true. So notice this does work, and this actually shows that since this point v2a plus 2b comma 2c satisfies the equation of RU, therefore it must also lie on the intersection. So therefore all three of these lines all pass through this point here. So this point V exists, and indeed all the medians have to meet at one point. So that is, if you try to do this normally using just standard geometry here, it's going to take you a long time and a little bit more firepower than we have right now. But by doing this algebraically, it turns out that this works out really, really nicely using just our techniques of algebra and a little bit of using a little bit of elbow grease here. But now, there are a couple of other things to note here that I really want you to focus on. So notice, if we go back here, let's take a look at this. If you remember, back in our original problem, back in the original here, right? Back in the original picture that we had here to start, right? Let's look at the coordinates yet again. 0, 0, 6a, 0, and 6b, comma 6c. So 0, 0, q is 6a, comma 0, and r is 6b, comma 6c here. And then we also have v as 2a plus 2b, comma 2c here. You'll note that if you look at this carefully, in a way, we see that 6c here, this is exactly triple 2c here. And here we have 6a and 6b, and this is 2a plus 2b here. So almost like this is exactly triple that. So it's almost as if I can take these, I can add them together, and get 6a plus 6b, comma 6c, and then divide it by 3, and get that. But wait a minute, where have we seen that before? When you take three things, you add them up, and you divide by 3, that's just the average. That's just the arithmetic mean here. So that means we note here one important thing is that the coordinates of the centroid of a triangle is just the average of the coordinates of the vertices. Very nice little thing here, okay? Furthermore, and this is a nice little thing to really focus on here. Let's focus on this. Let's look back at our picture now that it's all finished. If we look at PS here, right, we note that P00, S is 3a plus 3b, comma 3c, and we have V is 2a plus 2b, comma 2c here. Now note that V looks just like S, except that, well, all the 3's got replaced with 2's. So if you think about what's going on here, this is almost as if PV is 2/3 of PS here, right? This should remind you of the dividing a segment into an M to N ratio that we looked at a week ago or so. Note that this PV here looks like PV equals 2/3 of PS here, right? It looks like that. Now wait a minute, if PV is 2/3 of PS here, that means this piece, PV to VS here, has to be a specific ratio, because if this is 2/3 of the entire thing, this is 2/3, that's 1/3, that's a 2-to-1 ratio here. So we seem to have 2K and K here. So it seems like there's a 2-to-1 ratio here. Now, note that you can kind of do the same thing over here as well. You can verify this yourself, or you can use the distance formula to verify this yourself and see, wait a minute, that's the same thing here. So from 3c down to 0, 2c is 2/3 of the way down. From 3b to 6a, this is exactly 2/3 of the way there as well. So that's also in a 2 to k, so I'll call this 2L and L. And the same is true here. This is going to be 2M and M. So the last thing, probably the most important thing here, the one that you really want to focus on, is this. You want to focus on the fact that the centroid divides each median into segments in a 2-to-1 ratio. Now, note that the 2-to-1 ratio business here, ladies and gentlemen, is always from the vertex to the midpoint here. So if this is our vertex, and this is the midpoint here, okay, and this is the midpoint of the opposite side. Note that what we have here, this 2-to-1 business here, this is our centroid. It's always from the vertex to the midpoint. So that means the centroid is actually closer to the midpoint than it is the vertex here. It's always going to be in a 2-to-1 ratio here.